Good afternoon. We are Team Mecha Lectric. Our project is the electric Ford Ranger. I am the project manager, Timothy Moore, a mechanical engineer. Our team members are Artemio Anguino, a mechanical engineer, Jack Lee, an electrical engineer, Joshua Rowe, a mechanical engineer, and Blaine Tupin, an electrical engineer. The outline of this presentation will cover the background of the electric Ford Ranger conversion, the scope of the deliverables, the overall timeline, and the probable outcomes.
Hello, my name is Artemio Anguino, and I am here to talk about the background of the Ford Ranger. Previous capstone groups have taken apart the Ford Ranger and removed the main components of the vehicle to modify and to use for our capstone project. The main components, such as transmission and the transaxle, were removed to be modified. By removing the main components, we can assure how much space we are dealing with when the assembly of the modified parts will come. As you can see in the image, the engine bay has been cleared from all the main parts. With the previous capstone groups working to remove parts of the Ford Ranger, they also removed all the unnecessary parts such as the truck bed, air intakes, AC components, and the components that were associated with the engine. As you can clearly see in the image, all parts associated with the engine have been removed to assure more space when assembling the modified parts.
Hello, my name is Jack Lee. For this project, a previous group decided that the ideal motor to utilize is a Curtis 96-volt dual motor. It was chosen as it is rated for a vehicle of up to 4,500 pounds and is also capable of being operated with a DC power supply. The graph to the right was pulled directly from a distributor's website. There are 4 variables that are mapped out for us: torque in orange, horsepower in red, the battery current in or battery voltage in olive green, and the DC current in emerald green. As seen on the graph, when the DC current and the horsepower at their peak, the battery voltage dips. This decrease in voltage at max performance denotes that it is an efficient motor. A separate group previously fabricated the battery box that can be seen here. It houses 8 separate 12-volt batteries that have been connected in series. Its construction was done with consideration to the voltage and amperage draws that will take place during operation. All connective wires were selected to withstand operation at peak output. The batteries will also be connected to the generator to recharge them.
Go back one, please. Hi, my name is Joshua Rowe. As my colleague stated, the batteries incorporated into this design tend to draw massive amounts of electrical power. As a result, the losses due to heat build up and require cooling. To dissipate the heat, this battery box utilizes 2 main methods of cooling, which consist of convective heat transfer of the air and the conductive heat transfer between the batteries and the aluminum casing. The fans incorporated ensure that there is constant flow over the heat concentrated areas of the batteries, while the aluminum casing acts as a pseudo heat sink exposed to the outer temperatures. The previous team arranged these batteries in such a way that the maximum heat dissipation would be achieved without sacrificing too much space. It is speculated that this team chose to use aluminum due to its low density and ease of machining, as well as its thermal conductive properties, which are only second to copper. Moving on to another team's contribution to this same project, we have the pneumatic shifter. The shifter mechanism is mounted onto the transmission of the vehicle and serves to essentially change gears pneumatically and utilizes push button technology to which allows the engine to not exceed the optimal RPMs as previously stated, for which maximum efficiency is defined. There are 4 speed controls and a reverse, which correspond to a total of 5 buttons. This array is connected to the mechanism through standard wiring and is to be mounted by our team, as we will later discuss in the scope of our project.
The overall scope of the project consists of collaborating with Turbonetics to have the transaxle adapter fabricated from an aluminum billet. Afterwards, we will proceed to mount the battery box onto the truck frame near the rear of the Ford Ranger. Once we have the transaxle adapter, we can mount the transmission transaxle assembly to the motor and then mount that to the overall transaxle frame. After that, we can mount the throttle to the truck, then route and connect all of the cables to the electrical system. Once that is completed, we will mount the generator into the engine bay of the vehicle and connect the wires to the battery box to enable charging of the electrical system. During this process, we are taking down the item numbers, the nomenclature, the SKU, as well as the price and order receipts to develop a bill of material for the approval, build, and installation of the hardware to keep an accurate record of all of the materials used during the fabrication and completion of the electric Ford Ranger project.
Hello, my name is Blaine Tupa, and in this slide we'll look at the overall timeline for the project. Starting in late August, we looked to collaborate with Turbonetics to fabricate a motor to transaxle adapter. While this is being fabricated, we will obtain the necessary equipment to mount the motor to the adapter, primarily looking at bolts that will be able to withstand the load. After these are connected, we will then look to connect it to the transmission of the truck. And once these are all connected, we will then find the necessary equipment to mount all the entire assembly to the frame of the truck. Once this is all mounted, we will then connect the pneumatic shifter to the electrical part, and we will test the shifting mechanism for it. Once this is tested, we will then connect the battery box that was discussed before to the bed frame of the truck. And once that is properly mounted, we will then look to mount the throttle and connect the throttle properly throughout the truck. And then by the end of mid-December, we will look to have the entire project completed.
The probable outcomes are obtaining the transaxle adapter from Turbonetics. They are a little bit backed up. We are waiting on them to fulfill the order that we submitted to them. The battery box will be mounted to the truck frame. The transaxle adapter will join the motor and the transaxle, which contains the transmission. The assembly of the transaxle will be mounted to the truck frame. We are designing a throttle that will be mounted to the truck, and the cables will be correctly routed in order to have variable speed capabilities. And the bill of material will have all the parts included in the overall design and fabrication on it, and we will submit that with our final presentation report.